In this video, I want to show you how to use permutations to count possibilities. Okay, this will help you with the 12.5 objective for your Khan Academy assignment. Okay, permutations, first off, what a permutation is, it's, here's an example. Let's say I have the letter home. It could be any word. Okay, but I have 4 letters, and the question is, I want to know how many different unique words can I write using these words. They don't have to make sense. Okay, so here's one way. I could say HMOE. I could write HEMO. I could write all sorts of different words. Okay, so in general, the way we would do this. Okay, I mean, listing them all would take a long time. Let's just think about it. Okay, I have 4 letters I can choose from. Okay, 4 letters I can choose from, and there's 4 letters total. So the first letter, well, there's 4 different letters I could choose from for the first letter. Okay, after I chose the first letter, there's 3 letters left. So there's 3 letters I can choose for the second, and then 2 for the third, and then 1 for the last one. Okay, and but from our counting lesson, we know that we can multiply them together to get our total combinations. So 4 times 3 is 12, times 2 is 24. So there would be 24 total 24 different unique words you can write from these 4 letters. Okay, that's permutations. It's where the order matters. Okay, sometimes order doesn't matter, but here it does. Okay, the 4 times 3 times 2 times 1, we can actually write that as 4 factorial. Okay, we don't say 4 like we would exponents, or not exponents, exclamation marks. This means 4 factorial. That means 4 times 3 times 2 times 1. Okay, all right. So some more on factorials, like 2 factorial, that'd be 2 times 1, which is 2. 5 factorial, 5 times 4 times 3 times 2 times 1. 20 times 3 is 60 times 2 is, so this would be 120. 7 factorial, you could probably figure that out, and also you could probably do 8 factorial. Okay. Alright, so here's an example. Band competition. 12 marching bands are entered in a competition. You can use the counting principle to count how many ways first, second, and third can be awarded. Alright, so if you think about it, I have 12 bands, and we're awarding first, second, third. So there's 12 bands that could be first, there's 11 bands that could be second, and there's 10 bands that could be third. So how many different orders could they be awarded first, second, and third? Well, you'd multiply those 3 together and get 1,320. Okay, so that's an example of a permutation. Okay, notice that this one isn't 12 factorial because I do 12 times 11 times 10, and then I stop. I don't keep multiplying. Okay, let's try number 4. Chris wants to see 4 movies that were released in the past month, and how many different orders can Chris watch the movies? Okay, so we have 4 movies. Alright, so how many different orders can he watch it? Alright, well, he can choose between 4 different movies for the first one. He can choose between, once he chooses that one's out, so there's 3 left. So the second, the movie that's shown second, there's 3 different ones there. So 2 for the third movie to see, and then, okay, all the others are played, so there's only 1 option left for the fourth. So altogether it'd be 4 times 3 is 12, times 2 is, so 12 times 2 times 1, 12 times 2 is 24, 24 times 1 is still 24. So this would be 24 different ways. Okay, and then how many ways can 7 runners finish in first, second, third? Well, I have 7 runners. Okay, first, second, and third. Okay, there's no 4th place. So there's 7 different runners can finish first, 6 different runners can finish second, and third, well, it'd be 5. There's 5 left to choose from for the 5th. So multiply together, and you have your answer. All right. Okay, there's a formula that we have for permutations. Okay, we write it like this: n. Okay, so P stands for permutations. We choose n things r at a time. So like before, where I had 7 people, and I wanted to know first, second, third. So we would write that like this. Okay, I'm finding the permutations 7 different things, and I'm picking 3 of them. So that's 7. I'm choosing 3 at a time. All right, and then okay, the formula for that is you take n factorial, so the numbers, so it'd be 7 factorial over, we take the amount of things we have, and then we subtract how many we're taking. Okay, so, and then we write it like that. So we put n in for n, and r goes in for r. All right, so that would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial. Okay, so that would be 7 factorial over 4 factorial. And 4 factorial is 4 times 3 times 2 times 1. All right, let's look what happens. This is division, so I can divide both by 4, both by 3, both by 2, and both by 1, and they're gone. So I'm left with just 7 times 6 times 5, which is what we did. Okay, so number 5, okay, I'm choosing, I have 7 spots, or 7 things. I'm choosing 4 at a time. So one way to think about that would be I have 4 spots, and I'm choosing 7. There's 7 things to choose from. So I can choose 7 for the first, 6 for the second, 5th, and 4th. You could also use the formula. That'd be 7 factorial over 7 minus 4 factorial. Okay, so that would be 7 minus 4. That becomes 3. Okay, so on the top you would have 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, 3 times 2 times 1. Okay, 3's cancel, 4's cancel, or the 3's, 2's, and 1's cancel. So you're left with 7 times 6 times 5 times 4. And that, once you multiply, you have your answer. Okay. If on certain calculators they actually have factorial buttons, well, let's do number 7. So I'm choosing 3 things, or I have 3 things, and I'm choosing, this would be like having 3 runners, and I want to see how many different ways they can take first, second, and third. Alright, so there'd be 3 ways for that, 2 ways for that, 1 there. There'd be 6 total ways to arrange this. Alright, and then for 11, I have, okay, I have 11 different runners in 2 places. Okay, so that'd be 11 and 10. So this would be a total of 120 would be my answer for 8. Using my formula, I would have 11 factorial over 11 minus 2 factorial, which is 9 factorial. So pretty much 9, 8, 7, 6, 5, 4, 3, 2, 1 is going to divide out for both. We're left with the 11 times 10, which gets me the, sorry, that's not right. It's not 120, it's, sorry, 110. 110 is the answer for number 8. Okay, because 11 times 10 is 110. Okay, number 9. Okay, so example 1, you found the number of permutations of 4 seed taken. How many at a time? Explain. Let's not do that. Okay, let's take a peek at one of the Khan Academy exercises. Okay, so if I go here, we want to learn permutations. Okay, let's just do permutations, not we're not doing the combinations yet. Okay, and then the permutation exercise is right here. Okay, so how many unique ways are there to rearrange the letters in the word fancy? Okay, well, you could do okay, you could try listing them all. Okay, but if you think about it, you got 5 spots. Okay, and then there you could choose 5 different letters for the first spot, 4 for the second, because you already choose the first one, so there's only 4 left. Okay, so 3 for the third spot, 2 left, and 1. So then multiply together. So this will get you 20. 20 times 3 gets you 60. 60 times 2 gets you 120. Times 1 is also 120. So 120. Alright, and it's good. Let's try out one other. Okay. I think we're good. Done.